Every Tesla you've ever seen, every electric vehicle you've ever considered buying, they're all about to be relics of a bygone era. Because Elon Musk just declared war, not on a company, not on a country, but on an entire industry. And it only took 3 words to do it. End of lithium. Let that sink in. This isn't marketing hype. This isn't a clever tweet. This is Musk lighting the fuse on a technological revolution that will explode everything we thought we knew about. Electric vehicles, the weapon, a next-generation aluminum-ion battery that's already under development for the 2026 Tesla Model 2, and the price? Brace yourself, just $1,795, while mainstream media obsesses over range anxiety, grid limitations, and charging speed. Musk has been quietly dismantling the very foundation of the lithium-based AV world. His warning about upcoming power generation issues wasn't just a casual comment, it was a strategic message. Lithium isn't just expensive, it's limited, it's geopolitically volatile, it's unstable, and most importantly, it's reaching its limits. That's why Tesla has shifted gears and pulled the curtain back on what could be the biggest energy leap in 100 years, the aluminum-ion battery. And in this video, we break down why this $1,795 battery isn't just real. It's Tesla's most dangerous invention yet. From science to supply chain, from factory floors to Mars-ready durability, we'll expose the secrets behind this technology and reveal just how close Tesla is to making the world's first mass-market EV that's powerful, affordable, and nearly indestructible. Make sure to hit that subscribe button, ring the notification bell, and join our rapidly growing Road Zone Reviews community, because you're not going to want to miss what comes next. Let's get straight to it. A $1,795 Tesla battery pack doesn't just sound like science fiction, it sounds like financial suicide for the competition. But once you understand Tesla's material strategy, their manufacturing breakthroughs, and vertical integration playbook, the price tag stops being shocking and starts feeling inevitable. The magic starts with one word: abundance. Unlike lithium, which requires brutal mining, international transport, and high environmental costs, aluminum is everywhere. It's the third most abundant element in Earth's crust. There are mountains of it in nearly every industrialized country. In 2025, aluminum costs roughly $2,000 per ton. Lithium, over $15,000 per ton. That's a 7-to-1 advantage before a single battery is built, but Tesla didn't stop at cheap materials. Back in 2019, they quietly acquired Maxwell Technologies. While the media saw another acquisition, insiders knew what was coming: dry electrode manufacturing. This process doesn't just save space and energy, it slashes energy consumption by 70%, eliminates the need for toxic solvents, and cuts factory space in half. Tesla's Kato Road facility has been perfecting this tech ever since, and it's now being adapted for aluminum-ion cells. Meanwhile, Aerosol Fusion, Tesla's joint venture with the University of Texas, cracked one of the hardest parts of aluminum battery chemistry: consistent stability. This was the missing piece that held aluminum batteries back for decades. Now, it's solved. Stable, cheap, scalable energy is no longer an idea, it's a product. Let's talk infrastructure. While legacy automakers like Ford and GM outsource their batteries, often overpaying for CATL or LG cells, Tesla plays a completely different game. They own everything. From raw material contracts to in-house cathode development, from software to hardware to energy management systems, Tesla is the supply chain. Their gigafactories in Fremont, Shanghai, Berlin, Austin, and soon Mexico form a global battery empire. And by 2026, Shanghai and Texas alone will be producing Tesla's 4,680 cells at full tilt. This same infrastructure will support aluminum-ion production, instantly enabling a 30% cost reduction compared to lithium-ion cells. Now, let's break down that famous price tag. $1,000 raw materials, labor, and cell production. $500 amortized research and development and engineering costs. $295 Tesla's margin total. $1,795 for a 60 kilowatt-hours aluminum-ion battery pack, which translates to just $30 per kilowatt-hour. For reference, today's lithium-ion packs sit between $100 to $150. That's not just a price cut, it's a market bloodbath. But cost is only half the story. What terrifies Tesla's competitors is scale. Tesla's casting technology already uses massive aluminum parts to build Model Y chassis in one piece. Now imagine using that same casting infrastructure to mass produce battery housings and modules. They're not just building a car. They're building the template for total energy dominance. But here's the burning question. How close are we really? Is this aluminum battery a future dream? Or is Tesla already testing it right now? Insiders say it's happening right now. Behind closed doors, Tesla's Cato Road and Fremont facilities are producing 100 to 200 prototype aluminum-ion cells per day. This isn't lab science anymore. It's a pilot production line, gearing up for scale, and that's not all. Giga Nevada is currently stress testing these batteries in high-load environments, replicating everything from urban stop-and-go to highway endurance. The early data? It's almost unbelievable. Tesla's aluminum-ion packs are showing 99% capacity retention after 10,000 full charge cycles. That's 5 times the lifespan of lithium-ion. Tesla's secret? Their addition of fluoroethylene carbonate, a compound that radically improves moisture resistance and thermal stability. This solves 2 of the biggest challenges in aluminum battery tech: electrolyte degradation and humidity vulnerability. And it gets better. Tesla's partnership with the University of Queensland, a world leader in aluminum-ion battery research, gives them exclusive access to materials science breakthroughs that no competitor has. This is a strategic advantage that will be nearly impossible to replicate. Yes, challenges remain. Solid-state electrolyte synthesis still presents manufacturing hurdles. Tesla's 4,680 development saw early waste rates of 70 to 80%, but now they're building 500,000 cells per day. That's what sets Tesla apart. Their brutal, relentless ability to iterate until they win. So what does the future look like? Tesla plans to unveil the Model 2 in late 2025. With production beginning in 2026, select trims will launch with aluminum-ion batteries, and by 2027, the full lineup will transition. The battery pack, priced under $1,800, will offer up to 600 miles of range. That's more than a Lucid Air, more than a Mercedes EQS, and at a fraction of the price. But here's where things go global. What if the $1,795 battery wasn't just for cars? Tesla is already designing microfactories, decentralized battery production units that can be deployed anywhere on Earth. Why build one mega gigafactory when you can build 1,000 microfactories that produce aluminum-ion batteries locally? A 2024 Nature Communications study confirmed aluminum-ion chemistry is modular, abundant, and low risk, making it ideal for local manufacturing. This opens the floodgates for hyperlocal EV production, rural areas, developing countries, disaster zones. With logistics costs slashed by 40%, Tesla could produce EVs anywhere on the planet, and let's not forget extreme environments. Aluminum-ion batteries remain stable from -40 degrees Celsius to +80 degrees Celsius, something lithium-ion can't even dream of, whether it's the Arctic, the Sahara, or the Martian surface. Aluminum-ion batteries don't flinch. You heard that right. Mars, Tesla's rumored collaboration with SpaceX positions this battery as the future of off-world power systems. Light, stable, and energy-dense, aluminum-ion is a candidate for lunar rovers, satellite systems, and Martian habitats. Model 2 becomes more than a car. It becomes the testbed for extraterrestrial technology. But let's bring it back to Earth. This battery gives Tesla the ability to turn every Model 2 into a mobile power station. Imagine rural villages stabilized by fleets of Model 2 South. Picture emergency microgrids powered by Tesla batteries after a hurricane. Envision neighborhoods where cars don't just drive, they provide power, independence, and resilience. That's the bigger picture. That's the real revolution. We're not just watching the end of lithium. We're watching the beginning of decentralized, democratized energy access. The kind that doesn't depend on governments or oil empires. The kind that puts power back into your hands. So if you're ready to see a world where electric vehicles are affordable, where batteries power freedom instead of fear, then hit like, smash that subscribe, and join us here on Road Zone Reviews, where we track the innovations that others are too afraid to talk about. And remember, this isn't just about a battery. It's about a future that's no longer waiting to happen. It's already here.